There are countless questions in science, and more specifically in cosmology, that the James Webb Space Telescope will provide an answer. For Webb will gaze to the very first stars and galaxies to form in our universe and show us planets like never before, although the James Webb Space Telescope is not really an exoplanet hunter. With its 6.5-meter diameter primary mirror and infrared spectroscopy instruments, it is perfectly suited to peer more closely at distant worlds, telling us what they are made of and potentially if there are signs of life in their atmospheres. Astrophysicist Nicole Lewis says she will use some of her observing time with the James Webb Space Telescope to explore the exoplanet WSP-17b. A hot Jupiter exoplanet about 1,000 light-years from Earth. The telescope will spend 80 hours looking at a single planet in all directions using the broad range of instruments which will allow us to start to understand what the different parts of the planet look like. The James Webb Space Telescope will help us build a more complex picture of distant exoplanets over time by mapping them in more detail than ever before and looking at neglected wavelengths. Lewis says, when we look at planets we think of them as they look like an optical because of the light reflected off of them, but if you really want to tease into what makes them tick, you want to look at them in infrared, like if you want to know if there are organic compounds in their atmospheres. American theoretical physicist, mathematician, and string theorist Brian Greene is also excited about the prospect of the James Webb Space Telescope. He thinks it will have a radical impact in understanding our world. Year in science really already began. Maybe you want to mark it by that key moment, the launch of the rocket taking the James Webb Space Telescope out into space, when this Ariane rocket launched from French Guiana, taking the James Webb Space Telescope on the initial steps of a million-mile journey out to what is known as the L2 point, the Lagrange point, where the telescope will be in orbit around the Sun, keeping it aligned with the Earth, which will help the stability of the conditions of the rocket. But it's going to be a little while before anybody sees any data from that wonderful instrument, as it has to make its journey to its location, and it also has to begin the commissioning process. The solar reflector panel has to unfold and the instruments have to be brought online, so it'll be about 6 months, and no doubt for the project scientists as well as those of us who are rooting for this device to have a radical impact on our understanding of the world. It's a nerve-wracking period. I mean, think about all of that electronics, all of that delicate equipment that needs to not only withstand this powerful launch but work under the extreme conditions of space. So hopefully it'll all work. So far so good. It was really a picture perfect launch. So in the coming months we'll have further conversations about the telescope and give you updates on how it's doing. The first solar system found outside our own did not involve a main sequence star like our own, but a pulsar. Since then we have found thousands of exoplanets, and we continue to narrow in on smaller and more Earth-like planets. NASA's James Webb Space Telescope is getting ready to give us the best view yet of worlds beyond our own solar system. Scientists at NASA's Ames Research Center in California's Silicon Valley will be among the first to observe the cosmos with Webb, and they're looking for clues about how exoplanets form, what they're made of, and whether any could be potentially habitable. One of the reasons the James Webb Space Telescope will study the atmospheres of exoplanets is to search for the building blocks of life elsewhere in the universe. But Webb is an infrared telescope. How is this good for studying exoplanets? One method Webb will use for studying exoplanets is the transit method, which means it will look for dimming of the light from a star as its planet passes between us and the star. Webb will also carry coronagraphs to enable direct imaging of exoplanets near bright stars. Although the image of an exoplanet would just be a spot, not a grand panorama, we can learn a great deal about it. That includes its color difference between winter and summer, vegetation rotation, and weather, etc. Of course, by studying the atmospheres of different exoplanets, the best results we can possibly hope for is to find evidence of alien life. The vast number of stars in the universe strongly suggest life is not unique on Earth, but where is the evidence? I think the move from life to consciousness, the kinds of beings that would build what we would recognize as a civilization that may be extraordinarily rare. I hope it's not experience on planet Earth suggests it doesn't always go so well when groups who are separated try to come together and live in some larger collective. But again, as an optimist, how amazing would it be to converse with an alien civilization and learn what they figured out about physics and cosmology, and compare notes and learn from each other in some wonderful way. I love that idea, but if you ask me the likelihood of it, I would err on saying it may be so improbable that the conditions conspire to allow life to move to this place of consciousness that it might be rare. Of course, the more exciting prospect about the James Webb Space Telescope is to find planets that could potentially harbor extraterrestrial life, music. But Webb may also answer other exciting questions that could resolve some of the deepest mysteries about the universe. To better understand what we can potentially expect Webb to deliver, we can take a look at its 4 key mission goals: the search for light from the first stars and galaxies that formed in the universe after the Big Bang, the study of galaxy formation and evolution, the understanding of star formation and planet formation, and finally the study of planetary systems and the origins of life in the first stages after the Big Bang. The universe was a sea of particles such as electrons, protons, and neutrons, and light was not visible until the universe cooled enough for these particles to begin combining, and Webb will Study what happened after the first stars formed. This era is called the epoch of reionization, because it refers to when the neutral hydrogen was reionized, made to have an electric charge. Again, by radiation from these first stars. The study of galaxy formation and evolution is concerned with the formation of the first galaxies, the way galaxies change over time, and the processes that have generated the variety of structures observed in nearby galaxies. Galaxy formation is hypothesized to occur from structure formation theories as a result of tiny quantum fluctuations in the aftermath of the Big Bang. Webb will look back at the earliest galaxies to better understand their evolution. Star formation is the process by which dense regions within molecular clouds of interstellar space collapse and form stars. The Eagle Nebula's pillar of creation are some of the most famous birthplaces for stars. They come to be clouds of gas, and as the stars grow, the radiation pressure they exert blows away the cocooning gas. However, it's difficult to see inside the gas. The James Webb Space Telescope's infrared eyes will be able to look at the sources of heat, including stars that are being born. NASA's planet-seeking Kepler Space Telescope has helped us find thousands of planets. The Webb's powerful sensors will be able to peer at these planets in more depth, understanding the atmospheres and the formation conditions for planets could help scientists better predict if certain planets are habitable. Which brings us again at the most exciting stuff about the James Webb Space Telescope and its fourth and final goal: the origins of life. If we look at the atmospheres after the James Webb Telescope of many planets, I mean, there's now an estimate now that there's on order of 1 planet per star on average. So we've long known that the galaxy, hundreds of billions of stars, numbers of galaxies, hundreds of billions of galaxies, so we're talking about hundreds of billions of planets. And if we start to survey some of these planets, and one after the other, we just sort of find no evidence for any of the biological markers. It could be, of course, maybe life takes a radically different form. It'd be hard to know that, but I think that would at least give us some insight on the life question. But I just don't see how we get insight on the civilization or consciousness question without the direct connection. And it strikes me that if consciousness is ubiquitous, let's say life is, I'm willing to grant that if consciousness is also ubiquitous, then I don't understand why they haven't been here, because presumably they should be much further ahead of us. How unlikely would it be that we're, like, of all consciousness in the universe, we're the most advanced? That would be such a special place for human beings that it's hard for me to grant that as a likely possibility. Rather, I think we're kind of running the mill, and there are many who are far more advanced than us, and I don't think that they would expend the energy to hide themselves. Thanks for watching. Did you like this video? Then show your support by subscribing and ringing the bell to never miss videos like this. Music, you